Hi, good morning, everyone. Welcome to the Disaster Recovery Planning for IFS webinar. Thank you very much for taking the time and joining us. Let's start with quick housekeeping. As you've noticed that I have put all of you on mute. This is really just to improve the quality of the sound, as well as just to make sure that we have a clear run during this webinar. If you're having any problems with sound, maybe you want to close any online applications you have open at the same time. And if it persists, maybe you can contact Alex on the email provided. We will leave all the questions to the end, and you will notice that they will be referring to a number of templates and tools. So there is a sign on the right-hand side there that shows that whenever we show the sign, then there is documentation for you to look into. You don't need to take any notes really, because we will be giving you a folder, a Dropbox folder with the actual slides and the actual recording of this webinar. Frequently asked questions and any questions we get at the end of this webinar. We will be referring to a number of tools, online and offline, to do with IFS and Oracle and disaster recovery. So these will also be available in the directory. Alex will send you a password that enables you to get access to these directories. Very quick introduction. My name is Fouad Boras. I am the co-founder and managing director of Amal Consulting. My background really is around the IT and software engineering side, and I worked on the management side of IT, as well as actually on the consulting side, so you could see that I worked on both sides of the fence, and done some work on the disaster recovery and business continuity as a consultant, but also as a manager. Ofakar Khan, a senior technical and functional IFS consultant. He's one of our key e-helpers, and he specializes in disaster recovery around backup and replications. What we will be doing between us, I will cover the concepts and the metrics regarding business continuity and disaster recovery. I'll touch on the methodology and some of the tools, and Afak will actually focus on the technology, tools, and some of the options and scenarios. Very quickly, some of you have not dealt with Amal Consulting before. We are based in the UK near Manchester, focus on IFS. Our team provides remote and on-site support for IFS. A lot of it is very much providing hourly based support, assistance. What we are finding is that the majority of the work our clients need, it could take 1 to 2 hours to resolve, doesn't have to wait days or weeks. So basically we are providing as and when needed assistance across a number of areas. Going to the webinar, there are a number of things we would like you to walk away with. First of all, we just need to make sure that we set the scene right, what the business continuity and disaster recovery are about. We'd like to highlight one tool which we use regularly, which is about the business impact analysis to drive the right metrics for disaster recovery, and then touch on the methodology. The second area is regarding technology options for backup and for replication. And obviously the third takeaway is the number of tools we are using, and there is no reason why you cannot actually do some of the work yourself in terms of assessment and looking at the business continuity plans and disaster recovery plans for your organization. And hopefully these tools will give you some steer and structure. Many people think disasters are out of our control, the act of God. Recent research have found that 44% are hardware related. 32% are human induced or driven. skills, lack of it, lack of training. 14% are software, 7% viruses, and only 3% are actually to do with nature. What really this is telling us is that over 90% are something we can do something about. We can have the right strategy regarding disaster recovery, looking at the culture of the organization, looking at the technologies we use. But obviously one of the key things is to have the right risk management approach, both to prevent, detect, and correct. We'll talk a little bit later on about these areas. Some of the attendees might actually be familiar with what happened last Friday in the UK, and the Swanwick Air Traffic Control Center, who take control of the English airspace. Around 4 o'clock, all screens gone blank, no flight paths can be seen on the controller's workstation. And obviously, if you just look at Heathrow as an example, you're talking about an airplane taking off or landing every 30 seconds. So the idea that you actually don't have visibility over something as critical as this is quite concerning. And to be fair, it will be very difficult for the person in charge of that center with hundreds of planes, tens of thousands of passengers. It's a disaster in the making for this particular scenario. Thankfully, 36 minutes later, the system was back on. But without saying that hundreds of flights were cancelled, many were diverted to Europe, tens of thousands of passengers disrupted, and obviously the outcry from the public, the media, the government, and you can imagine the insurance and the legal aspect of this. So it's very clear that this is an example of an unexpected situation taking place, and the organization were successful in immediately getting the data back. The recovery time was 36 minutes. Now it's interesting, I don't know the targets for the Swanwick air controller, but they actually brought the system back within 36 minutes. Now if their target is 1 hour, then they were successful in beating that. If it's 5 minutes, then obviously they have missed that. And the recovery normal operation, even though the system was up, the backlogs and the various issues they're having, they think it's going to be 1 to 2 days. What actually was the cause is a software glitch. The management felt that the system had about 4 million lines of code, and they eventually managed to find the issue. They got it sorted. But what also was interesting is that the business continuity and backup plans for Swanwick were successful in making sure that there was no major incidents in the skies. The business continuity communication with the media, with the government, with the airport authorities were run successfully, and basically they managed to diagnose the issue and resolve it within 36 minutes. So you could look at this and say, okay, things went wrong, but they were successful in actually in getting it back quickly under control. So we will refer to this Swanwick through the presentation, but what is the difference between business continuity and disaster recovery? Business continuity usually deals with the overall business, the production facilities, the centers, the office, the company infrastructure, the personnel, whereas the disaster recovery focuses on the IT, in particular hardware, infrastructure, systems, applications, and so on. But what you will find is that overall, you have to look at these as one unit. You have to look at a strategy that actually looks at the business continuity with the people involved, obviously including the IT and the business processes, as well as actually the technologies. Any change in one of these areas will actually have an impact on the others. So if, for example, you upgrade from IFS 2004 to APS 8, it's a new technology, new architecture, potentially new hardware, that will actually have an impact on the processes of supporting it, backing it up, as well as actually the skills and capabilities of the people and the business continuity. And I think the key message here is if you make one change in one dimension, it's very likely will have an impact on the other three. So business continuity, there are 5 plans, and as you can see, number 5 is the disaster recovery plan. So the disaster recovery is a subset of the business continuity. And what you will find is that with this 1 week, obviously once things went wrong with the traffic controllers, they kicked off the business resumption plan, the emergency plans, communication with the media, etc., and made sure that the incident was case managed. And then obviously the disaster recovery, which is the software aspect, was dealt with. Now, there are 3 measures around the disaster recovery. Really should be the focus is preventative, and that's actually making sure things don't happen. Detective, if they do happen, you detect them very early on. And corrective, unfortunately, if something goes wrong, like what happened, then you need to recover very quickly. The question is, where should we really start focusing our effort and investment? Because there are too many processes and we need to be focusing our budget and our investment in specific areas. And this takes us to the first tool, which is the business impact analysis tool. And in here, what you do really is to identify the business processes which needs assessment in terms of risks to the business, sensitivity in terms of how long they can be down, and the impact that they will have on the customer, regulators, and financials, such as revenue, obviously. Give them a rating, and then you will give them a code in terms of how quick your reaction should be. And then there is an action plan once that code is required. Now the tool looks like a spreadsheet, okay, and then you'll have the function, and then you identify the process, you pick up the process from the selection, you identify which part of IFS is impacted, particular module, the location it talks about, is it online, is it in China, is it in head office, so you identify where the particular process is being managed from, and then you look at the risks. Is it time, you're looking at customer risk, financial risk, regulatory risk, and then you look at the sensitivities of time sensitivity, and then obviously the impact. I'll give you an example. So if I take, for example, on a sales function, you could look at Amazon or one of the .coms that rely on sales online. Let's assume they're using IFS and the CRM sales area is being looked at. Location obviously is web order online. Obviously the areas of focus for them will be, or the risk areas will be financial. Revenue will be hit hard if this goes down, and customer retention is going to be an issue if this is not actually up or getting in new customers. Now the time sensitivity is very much scored by how much time you can actually afford to be offline. So if, for example, you need this to be up immediately once it fails, you give it a score of 40. If you can cope with 4 hours offline, you give it 20. If you can cope with 4 weeks, then obviously 0. There is no much of impact there. So what you do, you just give it a score based on the time sensitivity, and then the customer, regulatory, and financial impact, you give them a score, and you sum them up. And based on that calculation, you will actually basically identify the type of recovery that you require. A AAA, immediate recovery. So I would expect this 1 week air traffic controllers will be a AAA, especially around the flight management. If I take, for example, staff management or catering management or finance, there might actually be just an A or a B, okay, that they say we can actually survive. However, flight control management will be a AAA. Where does the business impact analysis fit in within the methodology? As you would expect from any good project or any good initiative, you need to do a mobilization, identify the sponsor, develop a clear scope and aims, for the initiative, have a team representative from the business and IT and third party where is appropriate, and make sure we have a plan. And then you conduct the business impact analysis, which I think is one of the most important and difficult areas, because what you're trying to do here is to drive the recovery point objective and the recovery time objective. So what you're trying to do is to define the metrics to shape up your disaster recovery. And once you define the metrics, then you can actually go and determine the type of technology you need, whether it's replication technology, backup technology, business continuity, emergency kind of responses. All of that will be driven by the RPO and the RTO numbers. There is always a danger that the business will want everything to be up and running, but the key thing here is what is the RPO and the RTO, and we'll talk briefly about that later on. Now, once you've actually designed the kind of technology, that will drive the investment you need in purchasing the software, the skills, and the technologies to enable you to achieve that, and then you go ahead and actually deploy that, and obviously you need to be testing it on a regular basis and going through some stress testing. We've mentioned RBO for the one-way traffic controllers. They wanted to make sure they actually get the data back almost immediately. Okay, so for them, zero loss of data. For a manufacturing company, and some of the companies we work with, is the previous day, last backup midnight, for example, and they are quite comfortable to lose a number of hours. They just use the backup from the previous night. Okay, so they are comfortable that they will lose a number of hours and they just have to rekey it or deal with it. So the RBO is the maximum tolerable period in which data can be lost and you as a business can actually survive and carry on. The RTO is actually what you hear in a corridor, which is how long before the system is up again. So for one-way traffic controllers, took 36 minutes to get the system up. Now that doesn't mean it's business as usual. It purely just means the system is up, and this takes us actually to the recovery normal operation, which is when the business becomes business as usual. You deal with the performance issues, you deal with the logins, with the profile settings if there is any disruption there, and then also with any backlog. And then at a particular point, you will actually have business as usual activities. What is, I think this slide is showing, is that the business continuity is an overall picture, and the disaster recovery really is very much a subset of that. And what you see when a disaster strike is that on the left-hand side, what you're trying to do is to recover, get as quickly as possible data to enable you to proceed to getting the system back and actually getting the business as usual back as quickly as possible. Obviously, for every process, as I said before, you need to determine what is the RBO, RTO, and RNO for every process. And there will be some processes that they will be very short, and for some processes you are quite comfortable to stay with 2 or 3 days and sometimes even a month offline. I think food for thought for us is, do we know who is actually within our organization sponsoring the disaster recovery from the business and IT? Do we know the team? Do we really have a good visibility on the governance of that team? And the other possibly interesting questions for us is, what is the recovery point objective we're working towards for a particular process? What is finance, sales, or manufacturing? Do we really have a number that can actually drive behaviors and drive investment? And the same thing for RTO and RNO. Hopefully this sets the scene. I'll come back later on and talk a little bit about the health checks. So now I will hand over to Afak, who will actually basically be talking to you about some of the scenarios. And I'll just hand over now to him.
Thank you, Fuad. Good morning, everyone. Let me start with the types of IFS installations in customers. Yeah. Can I click here? Okay. We have worked we have worked with over 50 IFS companies over the past 8 years, and we come across many types of installations. I want to give you the 3 main types of IFS setup which are used mainly. In the type 1, in this type there is a single server, as you see in the illustration. There is a single server hosting the live system as well as the test DB and development environment. And they are using this server also for application server, for IFS application server, for file server, etc. And they are not getting backup of that server. They only get a single image time to time. And in this type, in this customer type, there is no IT department, and there is only one planning engineer involved in care of system, both IFS and Oracle, anything. And this seems to be the most risky type of IFS installation. On customer type 2, in this type there are 2 servers. One server has the production environment, as you see, and this is usually backed up cold. It means shut down database and copy all database files from the source to the destination. Probably it will be a different drive in the same server, nowhere else. And the other server contains the test database and development environment and file server and other things. The only production is separated from others, but still test, application and development are in the same server. Separation seems good and makes the production more secure, but still not the best practice. And the final type, there are 3 servers. One is for production, one is for IFS application server, and one is for test database and development environment. But still, production is backed up cold. And lastly, we frequently see that customers have these 3 types of IFS installations on virtual servers. This looks better to manage, but on database side, Oracle says that I don't give support to virtual servers. If you had a problem caused by a bug or anything caused by your virtual server software, then you are alone with your virtual server software provider. Oracle doesn't give support on these issues. And on the other hand, it means that to put all your eggs in one basket, because it is a single physical server and you deploy all your servers in it. I remember one of our customers had a problem on VM, virtual machine, and it took 2 days to get support and solve the problem. For 2 days' time, they were offline, unfortunately. We always recommend a multi-layered setup. As you see, there are 4 servers. One is for prod, one server for IFS applications, one server for test database, and one is for development environment. You may say, is it necessary to separate development and test environment? I can say no, but this is the best practice to separate environments from each other and reduce the risk. We are talking about disasters. Let's make the definition of disaster. What's a disaster in terms of IT? We should divide the disaster types into 2 main groups. And one is internally and the other is externally affected disasters. Internal affected disasters, we can say software problems like invalid backups, conflicts caused by updates or patches, or an IT person or a former employee can drop your table accidentally or for another cause. these are based on software problems, but there can be also hardware problems internally as well. Disk failures or electrical problems, like your RAID port problem. These are caused internally, and some other problems can be caused by external effects. For example, lack of grounding, earthing, while having a high voltage current caused by lightning, or fire outbreak can occur, or you can come across with a flood caused by a burst water pipe which is very close to your server room that you never know before. And more simply, your server room air conditioner can have a problem and cannot function and cause the server to shut down because of high temperature. I want to share some experiences we had before with real disaster examples for our customers. One of our customers tried to increase the RAM size that is allocated to Oracle, and the IT person modified the parameter file of Oracle database. You may know it is init Ora file. But he was not an expert nor DBA and forgot to check some other parameters which should be updated before executing and restarting database. And do you know what happened? Yes, boom. Their production database didn't start up again. They were a manufacturing company and has serial tracking for their products. They had to create serial numbers for any inventory, any stock in IFS system. But they were offline for 6 hours. Finally, they requested help from us, and till midnight we worked to recover their database. Finally, we did, but they were totally offline while having disaster. They didn't have a disaster recovery solution nor healthy backup policy, and the cost of that disaster was higher than the possible solution. And another customer of us, they purchased a new server, and at the weekend period, they plan to migrate their database on the new one. So they need to shut down their current server to get a full backup and copy all files to the new server and mount it. They expect like this, but it was not like that. They shut down their server and database in a wrong way. They were not expert. And this caused their backup not to function, not to work. As they postponed the migration to the next weekend, they say we don't have any time, let's postpone it to the next weekend and go on with the current server, and let's do it later. But unfortunately, they couldn't start up their production database because they shut down it in a wrong way, in a irreversible way. So they thought that they had daily backups, and they said we can restore in a few hours and recover this disaster. But their backup policy also was not based on Oracle RMAN Recovery Manager. So they were using cold backups, which I mean shut down your database and copy files from source to destination. And none of their cold backups were valid to be used. So what did they do? They found a working backup which was from 45 days before. Yes, it was created 45 days before of the disaster date. It was even an automotive manufacturing company. They tried to collect back the lost data for weeks as possible, but it was not. The cost of that disaster was 4 or 5 times of the possible replication or backup solution. Let's talk about what you can do to avoid software disasters for Oracle and IFS. First, you need to acquire IFS and Oracle skills you need an IFS, an Oracle skilled team or person, or you may want to outsource and do contracts on these issues to make your in-house periodical health checks and conduct housekeeping tasks. On IFS side, IFS application side, there are several screens that you can monitor and take care of your application. What are these screens? Like batch queue configuration screen, which organizes the background processes of IFS applications, you may know, or system parameters which are important to be set correctly and which can be vital in some conditions, or application message screen that creates error messages and warn you before a disaster comes. On Oracle side, there are many points to check. Table space sizes, archive status, alert logs, audit trade status, flash recovery area check, RAM allocation check, etc. These are Oracle database terms which you may not be familiar with. Maybe you are. There are several tools to analyze the structure or status of these processes with these terms. You can use third-party tools to analyze, as you see, and a single screen in IFS Admin Exe helps you to do these checks. To avoid disasters, in any condition, you should back up your production database. But you can say how, which method is valid. Mostly used way is traditional way. It is cold backup. You stop your database copy files. This is called cold backup. It has many disadvantages. Let's say them. It is based on shutting down your DB and copying database files from source to destination. It requires the database to be offline as well, and users are offline in that time. Users have to wait the copying process, and it depends on the size of your database. It may be bigger size, so they have to wait more. And also, shutting down and starting up database, let's say restarting your Oracle database, causes database caches to be cleared. So what happens? Database caches the most used procedures and response time is shorter with these ones. Oracle database puts these procedures into the cache, and next time when the users calls these procedures or packages, then the response time is shorter. But when you restart your database, it starts to do cache from beginning and think that you are getting backup at night time. At the night time, you restart and clear them again. This means that your database has the capacity to gain speed, but you are blocking it with daily starts any day. And third problem you can have, shutting down your database can break the background processes. There are background processes running in Oracle database you cannot see, but when you shut down your DB, they are also broken, and you can cause some other problems you may not know. The best practice of the Oracle database backup is hot backup with Oracle Recovery Manager, shortly say it is called RMAN. Why it is called hot backup? Because your database is still online while you are backing up. It is running and it is online. There are many advantages. Users and the system are online anytime. You are not shutting down or starting your database, so they are always online. I know databases which are online for almost 12 months, maybe more. They didn't restart. When you don't restart your DB, then it means no cache clearing happens. it causes continuous speed gain. It caches all the procedures packages and continuously speed increases. And you are not restarting your DB, so there is no risk of database background processes. You don't kill the processes in the background. And the best thing is it is totally free to use, to have. Just you have to know how to set up, and when you set up it once, then it works till you stop it. Also, you have an application server, and you have to get a backup of application server. But it is not like others. The difference is that it has no DB on it, so it doesn't create incremental data. So just an image of that server is enough for your disaster recoveries. You have also test and development environment in best practice architecture. For your test and development server, you don't need to backup. They are not vital, but optionally you can backup your test DB by using, again, RMAN. And for your development environment, you can get a single image of the server as we recommend for your IFS application server. But if you say we have another development DB on it, then again you can use RMAN to backup your development database. But in some cases, backup will not be enough itself, but you can say why. In disaster cases, restoring the database using a backup is not as quick as you think. It can take several hours depending on your database size and many other parameters. And after restore process, you stand up in a point which is before the current date, which we call RPO, recovery point objective. What I mean, think that you back up your database at midnight time, and when you have a disaster and need to recover database in 4 p.m. in daytime, things like that, you have to come back at midnight data. This means that you will lose data both while being offline and when you restore your database. And the worst case, if you had a disaster with your hardware, then you might need days to stand up. You will order new spares, new disks, new RAID board, etc. This shows us backup is not enough itself for business continuity. Replication solves this problem. What is database replication? It means that you have twin databases on separate servers which are following each other simultaneously. It is not like a data replication nor database file mirroring. It is a database replication. It's a specialty. The methodology is like this. In our replication solution, methodology, there are primary DB and standby DB. Primary DB creates log files in Oracle. There is an archive mode, you may know. It creates log files, and they are shipped to the standby server over FTP, and they are applied in the sequence order for synchronization. There are agents on both servers, primary and standby, which communicate simultaneously with each other. Primary server agent says that I'm sending you 2 log files, and standby server agent says, okay, I got 2 of them and now applying the first one. In any time, both of the servers are aware of themselves and aware of the current state. In other words, you have twin databases in different physical locations on the world. And these locations can be another room in your production plant or another branch of your company in a different county state. And the restore process is done by switching to the standby database to online mode, and this takes 2 minutes, 3 minutes as well. not much more. And after switching, you stand up with real-time data or 5 to 10 minutes previous data. It depends on your replication software. Users are online, as you see in the illustration, till a disaster happens. In disaster case, when their connection is lost with the primary server, you switch them to the standby server and let them go in minutes. You can create multiple replication nodes in order to reduce risks more and more. Think that you had a problem with your primary database and a problem with your first replication node, then you can switch to the second or third or fourth replication node if you have in different physical locations. This is to avoid multiple disasters. You can have multiple nodes in different physical locations. This question will help you to decide whether you need replication or not. The main question is how much time can you stand being offline? If you say, okay, it's okay for us to wait 6 to 8 hours, we have backup from midnight, we can re-enter the lost data, we can keep the data while we are offline, we have enough time to do this, then backup is enough for you. You don't have to invest for anything. You can use RMAN, hot backup, then you can go on. But if you say, our business is agile and we cannot stand more than half an hour, then the replication is a must for you. The best way to tell the difference between backup and the replication is, I think, airplane engine example. The second engine you see here is the replication solution. It is always live, it is always working, and it is always mounted. In a disaster case, you don't need to spend time to be online. And it will help you to survive. It is always online and it doesn't require any time to stand up. But this one is a spare in the warehouse, and this engine is in the warehouse and it is offline. When you need it live, you have to spend hours, which you don't have in emergency cases. Another point not to forget anytime is backup is not an alternative for replication, neither the reverse. Think that in database replication, if you drop a table in primary DB, then it will drop in your standby DB as well, maybe with 0 seconds delay, maybe 5 or 10 minutes later, but it will be dropped. So when you need that table, you have to have a backup and restore data from that backup. In the replication, what you did is repeat it on the standby database as well. What are the best practices for replication, Oracle database replication? For Oracle databases replication, Oracle is the market leader, and they have a product called Oracle Data Guard. It has many advantages, yes, acceptable advantages. There is 0 seconds delay between primary and standby databases, and it is totally free to have. But on the other hand, it has many disadvantages, like Oracle says it is free, but you have to get my enterprise edition. Probably most IFS users are using standard edition or standard edition 1. In enterprise edition licensing model, it is more expensive than the standard and standard edition 1, and it's based on, the licensing model is based on the core quantity. And if you had a virtual machine, virtual server, they don't accept this. They say what what do you have physically on your machine, how many CPUs do you have, how many cores do you have, then it is like something, if you have 2 Intel CPUs in your physical server and 4 cores in each, then you have to pay 8 times 16,000 Great Britain pounds, something like that, for your primary server, and that much for replication server. It is a big investment, and it is hard to configure. The data guard is hard to configure. You need to get help anytime. What is our alternative for Oracle Data Guard? What is our recommendation for Oracle Database Replication is F8 Shadow. There are 5 to 10 minutes delay between primary and the standby server, but it works on Oracle Standard Edition 1, and also Enterprise Edition. It has no licensing model based on core quantity nor any server resources. You can use full capacity of your resources. And best side, it is very cost effective according to the Oracle Data Guard. And there is a graphical user interface to check your replication status anytime in seconds. People want to be sure that whether their replication is going in the right way, so you can do your own tests in minutes. You can switch your standby database to read mode and connect via Oracle SQL developer something, and check your data, check your packages, check your procedures, and check your replication status anytime. Is it healthy or not? You don't have to do preparations for hours, like restore tests. For replication architecture, what is our recommendation? In software-based disasters, being in the same physical location gives you the advantage of using same network speed, without any loss of speed of your network. Think that your primary database server is located on the 15th floor, and replication server is in the 5th floor, in the same physical building, in the same physical condition. But in externally affected disasters like this one, your production database is here and your first replication server is here, then you need another replication point outside of your plant, outside of your company. You can create a second replication node outside, maybe in a data center. This is what we recommend for your replication architecture. You can have multiple replication nodes. Maybe one is in your manufacturing plant to encounter with software problems and get the advantage of using the same network speed. But in external affected disasters, you may need to connect the outside data center, outside replication point like this. We recommend to start with a health check to review where your organization is and deal with issues. And if you had a backup policy, then we say let's check the health of your backups and do a restore test and see if they are valid or not. But we strongly recommend to create a backup strategy using RMAN, Oracle Recovery Manager, because it is totally free, and once you set it up, it is enough, and it will go on until you stop it. So we strongly recommend to create a backup policy based on RMAN. And lastly, consider doing a replication if you are in the category of companies that cannot stand being offline more than half an hour. Okay, Thank you. Now I will hand over to Fuat again.
Okay, thank you very much, Afak. Appreciate that. Finally, I think it's very clear that many organizations actually have got current policies and processes at the moment for backup, for archiving, for replication, and what I think possibly many organizations could do with is self-assessment, health checks. As I said, we have provided a number of tools that you have access to. They will give you the questions you need to ask, and hopefully that will assist you with getting started. If you need assistance with regard to these health checks, then obviously we can provide you with some remote assistance. And it depends on the size of the organization and the technical landscape. That can be 1 or 2 hours, just giving you steer and validation, or where appropriate, we can connect and actually assist you with doing the health check. I think the key message here is there are a number of questions you need to engage your business with to determine the kind of RBO and RTO as we've been discussing, and actually determine the kind of technology and policies that should be done for replication and backup. And obviously the right investment being put in place to enable you to have a robust, watertight disaster recovery. So with that, we go to the last part, which is really Q&A. So I'll unmute you, and questions are welcome if there are any questions.
Hi, thanks. I've got a question. So we've been using IFS since 2009. We haven't really considered the way we can improve the technical layer since the original implementation. So some of our users are experiencing slow response from time to time. Usually this happens in specific weeks and times, seasonally. We also use what you could call cold backups, which means we pick users off a server during the night shift for a few hours. So I've got a couple of questions on the back of that. First one is, which health check is best for the system performance issues? And secondly, how do we deal with night shifts and reduce interrupting still? That'd be much appreciated.
Okay, I'll pick that. There was a bit of a cut at the end, but if I understand right, you are asking about which health check is best for dealing with system performance. And the other one is, sorry, I didn't actually get that. The other one is to do with backup.
Yeah, how do we deal with night shifts and reduce the interruption to them?
Okay, I think if I understand you right, you started your implementation in 2009 and you've been live since then. So if you haven't done any overall health check on the Oracle, on the business continuity side, then potentially it's actually having a holistic health check covering IFS, Oracle, and business continuity. It will be my starting point. But if you want to push me and say, just tell me about the performance, I would say the IFS technical health check, because that will look at the IFS indexing of regarding Oracle, the batch jobs, the queues, the background jobs. We'll look at basically the compatibility of IFS with Oracle in terms of version control. So there are a number of things that this particular health check will deal with and will highlight any bottlenecks in terms of performance related to IFS. What it doesn't do, however, it doesn't actually go and look at the Oracle daily, weekly, monthly monitoring parameters that has been highlighted by the previous slides from OFAC. So that's really regarding the performance. The other thing regarding backup, possibly you need the right policy around the backup, and maybe the hot backup using Raman, because that will keep you actually online. Maybe that's the way you go, but before you recommend, really, you need to do a little bit of impact analysis and decide on the best policy and then you actually put the technology to support it. But my initial feeling is really the hot backup rather than a cold backup for that, and hopefully that will not disrupt the night shift personnel. Is that okay?
Yeah, that's great. Thank you.
Okay. Any other questions? Okay. As I said at the beginning, if there are any questions you want to send us, info@amalconsulting.com, so we'll actually respond to that. Alternatively, you can give us a call. The slides and the presentation itself, recording, will be on the drive, the shared drive that Alex will send you a password to over the coming hours. And then again, if you need any assistance with the tools, please don't hesitate to contact us, and we will do our best to give you the right steer and support you. And thank you very much for joining us. I appreciate you taking the time. Bye-bye.